All right, Math 3 students, take out the note guide from last week that says 7.3 notes, right? There's a front side and a back side. Recall we, underneath on the first page, we defined the word histogram and we defined the word frequency table. And underneath those two words on your note guide, you have these histograms. And right there on the page 1 right here, you'll see this picture at the bottom of 3 histograms. And whenever we have histograms, we can describe the shape of histograms. So notice how the bars of this histogram are hanging out mostly at the right, okay? And if we're to kind of outline the top of the bars of this histogram, we call it, see how it starts tapering and going lower and lower? We call this the tail of the histogram. And so a histogram where most of the bars and most of the data is on the right side, we call it a histogram that's skewed to the left. The data is skewed to the left. As opposed to right here, notice how the histogram, you have the biggest bar in the middle, and the left and right side are roughly mirror images of each other. We call that a symmetric data. So the data on the right of the distribution are approximately a mirror image of the data on the left. Okay? Should say left there. I cut it off too shortly there. Anyway, what about if the data, most of the data is on the left? Then again, if we outline the top like with like a curve, if we outline the top of all the bars of the histogram, the tail would be right here on the right. We would call this data skewed to the right. So most of the data is on the left, yet we call it skewed to the right, where it's getting smaller and smaller. Lower and lower amounts of the data are on the right, okay? As opposed to skewed to the left when most of the data is on the right side and the lesser and lesser amounts of data are on the left. So that's skewed to the left versus skewed to the right versus symmetric. So if you're asked to describe some data, that's how we do it. So it's kind of the opposite. If most of the data is on the right side, we call it skewed to the left. If most of the data is on the left side, right here, look at the bars are mostly on the left, we call it skewed to the right, okay? But if it's right, if it's nice and balanced, we call it symmetric. Now, if you flip your page on the note guide, if you flip it, there's a way to summarize data if it's symmetric. If data is symmetric, the way to summarize the data is if we want to describe the center, we're going to use the mean. That means X bar. Okay, we're not going to use the median. If the data is symmetric, we use the mean to describe the center and the standard deviation to describe the variation. Remember, when I say variation, that means how spread out the data is. How does the data differ from each other? How do the values differ from each other within the data? That's what variation is. And we already took our quiz last week on standard deviation. So what I'm trying to say here is if you ever have data that's symmetric, then you need to use the mean and the standard deviation to summarize it. We summarize it by describing its center, and we use the mean for that. And to describe the variation, we use the standard deviation. But if you have data, notice here, when a data distribution is skewed, by the way, the word distribution just means a spread. When a data spread is skewed, like skewed to the left here, or skewed to the right here, then we use the median to describe the center, not the mean. We use the median. I'll put capital N for median. And we use a 5-number summary to describe the variation, not the standard deviation. Remember the 5-number summary we used for box plots, box and whisker plots? It was the least value, quartile 1, median, quartile 3, and the greatest value. Remember this is the 5-number summary? We use this to describe the variation if data is skewed to the left or skewed to the right, okay? So to describe the center of data that's skewed to the left, we use the median. Notice how the median would kind of balance it out. If all these bars weighed, let's say they weighed a certain amount of pounds, notice how the median right here kind of would balance out the whole histogram. Whereas the mean is too far to the left. That's why we wouldn't use the mean to describe the center if data is skewed. If data is skewed, we use the median to describe the center, because notice where the median's at. It's right here, and it'll balance out all the bars. And notice the same over here. If data is skewed to the right, see, most of the data is right here. Most of the bars are on the left side. That means this is skewed to the right. The median, notice how the median right here, it's this dotted line along this bar. The median would fall right here, and if these bars actually weighed something, imagine them weighing like 5 pounds each or something, you could see that the median would balance out the bars if we were to like balance them on a scale, so to speak. The mean, notice, would not balance out the bars, only the median would. So this is why when data is skewed to the right or skewed to the left, like here, skewed to the right here, in order to measure the center, we use the median in both cases, okay? That's what this is trying to say here on the back side of your note guide. And we use a 5-number summary to describe the variation. But if the data is symmetric, okay, if it's symmetric right here, we use the mean to describe the center. Look at it, it's right in the middle. Look at the mean, that's X bar. And we use a standard deviation to describe the variation. Remember, standard deviation is that nasty formula where we figure out how far every data values is from the mean, square it, and add them up. Remember, dot, 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 dot. And we use that 3-column process to do that. We did that last week. You would use that to describe the variation. If your data is symmetric, you use standard deviation to describe the variation. So 2 bullets for center and variation if your data is symmetric, 2 bullets for center and variation if your data is skewed. Okay, that's what the backside of your notes is all about. Now, last week, if you recall, we did one example on standard deviation. Notice at the bottom of your note guide on the backside where it says extra practice. Recall that we did this example. This is last Thursday. We did this example. And your histogram looked like this. You and I did it together for our notes. If not, go back and watch the video from Thursday. And the histogram looked like this. Notice that. And look at the question B here, okay? Question B says, which measures of center and variation best represent the data? Okay? So this data, most of the data is on the left. So this data, look at all the bars are on the left and it's kind of tapering down to the right. This data is skewed to the right. You can write down your note guide here. This is skewed to the right because most of the data is on the left. And so it's asking which measures of center and variation best represent. Well, I just got through explaining that right here. If it's skewed, then the median, here we go. If it's skewed, then the median describes the center and the 5-number summary describes the variation. That's our answer. Which measures of center and variation best represent the data? The median and 5-number summary. That's the answer. Put a dash between 5 and number, is that right? Let me check here. Yeah. Because it's skewed, the median would be the best measure of center, and the 5-number summary would be the best measure of variation. And look what this says here. A weather station lists the top 20 snowiest major cities. The city in 20th place, in other words, the city in last place had 51 inches of snow. How would you interpret the data? Well, look at this histogram, the one we did last week. Okay, this is the same histogram we did last week. Yours looks a little different because you have your own drawing of it. But 51 inches would be about right here. Would be on this bar. Okay, right there. Because this is snowfall in inches, and this is how many cities, 2, 4, 6, 8, 10, 12 cities had that kind of annual snowfall. And they're saying, look, out of 20, the 20 snowiest major cities, the last place had 51 inches of snow. So last place was right here. Okay? If that's last place, look at, there's only one city above, there's only one city here and one city here, and they're saying that the last place of these top 20th place of these top 20 snowiest places would have 51 inches. So the last place would be in this bar somewhere. That means this list did not have all the cities. Okay? Actually, it's the other way around. This histogram did not have all the cities. If the 20th place had 51 inches of snow, then there's some cities in this table here. There's some cities in this table that do not have some of the snowiest cities. So remember, this was, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 18, 19, 20, 21, 22, 23, 24, 25. So out of these 26 cities that we made a histogram for, most cities were not on here. Most cities were not here, were not listed. Because if this radio station, this weather station says, hey, look, 20th place was right here. If 20th place was right here, that means there'd be 19 cities above this bar. But we only have like 2 cities here, 1 and 2. That means most cities were not in this list, most of the snowiest cities. That's what we can conclude. So it says, how would you interpret the data? We could say most cities are not listed here. Okay, that's for C on your note guide. And this one is not on your note guide. So look at this example. You don't have to write this down. Just pay attention to what I'm saying here. You don't have to draw this. Just pay attention. This is just an extra example I want to discuss here. So I have a histogram. And what is the shape of this histogram? Is it skewed or symmetric? Well, it's roughly symmetric, right? Even though it's not exactly symmetric, notice how the left side and the right side are somewhat mirror images, okay? It's roughly symmetrical. So we can describe, even though it's not exactly, the right side and the left side are not exactly mirror images of each other, when you're asked to describe a histogram, you just want to roughly do it. This is roughly symmetrical. So we can say this is symmetrical. Okay? Doesn't have to be exact. Whenever you're asked to describe something, that's not an exact kind of thing. It's just this is about symmetrical data. This is roughly symmetrical. And if I asked you, what's the best way to measure the center? Well, let's go back to page 1 of our notes. Actually, page 2. If it's symmetrical, the best way to measure the center would be the mean. Use the mean to describe the center and the standard deviation to describe the variation. So for that example, x bar, which is the mean, would be the best center. X bar is the best center, is best center. You don't have to write this down, just want to discuss this. And the standard deviation is best measure variation of variation. All right, go on to your next mission of the day. You're done with your notes.